Hello there, everyone. Welcome to Live Interactive English. I am Mike.
And I'm Matt, and today we're looking at examining the birthday problem.
Yeah, the birthday problem. Now, this is a very confusing title, and it's only a one-day article, so we're going to have to find out what this is all about. But what do you think the birthday problem is? I can think of many problems with birthdays.
One problem I have every year is that I keep getting older. So
that's a problem.
That is a birthday problem that I've been having.
I can only think of one way to solve that problem.
Yeah?
Never have another birthday.
That's a good idea. So if you just stop having birthdays, you can just stop aging.
But stopping from having birthdays also kind of means dying. You don't want to do that. That's not a good way to solve that problem.
Well, I can just stop telling people and then no one will know. I'll just be, you know,
just lie about your age.
25 forever.
Forever. You're looking really good for 22.
Yes.
My problem when I have a birthday is I don't like birthday cake.
Oh.
Yeah, it's a problem I've had for a long time.
So how do you solve that problem?
I have a birthday pie.
Birthday pie, all right.
Problem solved.
That is problem solved.
All right, there we go. Thanks everyone for watching the show. We'll see you. No, that's not the birthday problem. We actually do have a real birthday problem. And here's the problem with our birthday problem. It's a math problem.
That's right, math problem. I'm not a big math expert. I'm not a mathematician, but
I have problems with math and also birthdays. Anyways, the article will explain everything, I'm sure. So let's check it out, and then we'll be back to talk about it.
Question. In a group of 23 people, what is the probability that 2 people share a birthday? A. 5%, B. 10%, C. 20%, D. 50%. The answer is 50%. That may seem incredible, but the math is correct. This is the birthday problem, and it highlights a common mistake when we're calculating probability on a large scale. To begin with, 2 people have a 364 out of 365, or 99.73% chance of having different birthdays. This part is easy to understand, but things get trickier when we start comparing more people. In a room of 23 people, it might seem like there are only 22 comparisons to make, one person's birthday compared to the birthdays of everyone else in the room. In truth, there are 253 comparison pairs.
Welcome back. Today we are examining the birthday problem. And as we said, the birthday problem is actually a math problem and not my problem with getting older.
Nor my problem with not liking cake. These are small problems. This is actually an interesting problem.
That's right.
Yeah.
So we've got a question. In a group of 23 people, what is the probability that 2 people share a birthday? So A, 5%.
Okay, 5%.
B, 10%.
10%.
C, 20%.
20%.
Or D, 50%.
50%, so half. So basically, if you get 23 people in a room and you ask each person, when is your birthday? My birthday's July 4th, August 7th, September 2nd, whatever. What's the chance that 2 of those people will be born and have the same day, the same birthday? 23 people, 5%? It's got to be really small.
That's 5%?
Very unlikely.
I would think at least 20%.
Really?
Because, well,
I'm just thinking, like, in my school class, I don't remember anyone having the same birthday as me, and that was, 25, 30 kids, right?
that is true. I don't remember having a classmate growing up who had the same birthday as me.
I think maybe a few people in my life I've met.
Many had the same name as me, but not the same birthday. Many students named Matt.
Oh, I see. Oh, I thought the same last name.
No.
Okay. All right. So anyway, what's the answer? Let's find out the answer to this question. All right. The answer is 50%. 50%. That's incredible. That may seem incredible, but the math is correct. So basically, if you get 23 people, ask each one has the same birthday, it's a 50% chance that you will find a match with even just 23 people, even though there's 365 days in a year.
Yeah.
when you could have a birthday.
So that means if you have 2 separate classes of 23 people,
right?
one of those should have 2 people with the same birthday.
Guaranteed, if you follow the math. Now, here we're, of course, talking about percent. That's that little symbol you see with the circle, a line, and another small circle. When we say percent, basically we mean out of 100. Per 100. Cent, C-E-N-T, or cent, is the French word for 100. So when you see 2%, that's basically saying 2 out of 100. We use this to understand how often things happen, how likely things are to happen, that kind of thing.
And how well you do on your tests.
Also, how well you do on your test, or what chance there is that it will rain today, or something like that. So, for example, we could say Harold spends about 30% of his income on rent, which is pretty typical. So let's just say Harold makes $100. Out of that $100, he spends about $30 paying for his rent.
Okay, $30 would be very cheap rent.
Well, but maybe he makes $100,000 in a month, then he would spend $30,000 on his rent.
Sense.
Yeah, that's not incredible.
Okay, well, that's incredible is another vocabulary word, and it's an adjective. Incredible means amazing, but also somewhat unbelievable. Yeah. So it's incredible means if something is credible, it means it's easy to be believed. You can trust it. If something is incredible, it means untrusted, but also it just means something amazing in the way we use it most times. So her story is so incredible that some people think she made it up.
Oh, okay. So there we're kind of using the word in both ways. The story is hard to believe, but also it's just an amazing story. It will blow your mind. All right, so it is kind of incredible that in a group of 23 people, there's a 50% chance that 2 of those people in that small group will have the same birthday. Now, how does that work?
Okay, well, let's see. This is the birthday problem. Okay. And it highlights a common mistake when we're calculating probability on a large scale.
So how do we figure this out? How does this work with the math? Well, follow along. To begin with, 2 people have a 364 out of 365, or 99.73% chance of having different birthdays. All right, I kind of understand that. There's 365 days in the year. My birthday is on one of those days, so I would have a 1 in 365 chance.
What about the people born on a leap year?
Well, we'll not talk about them. They only have a birthday every 4 years.
Just make the math more complicated.
Exactly. Let's get back to the article. It says, this part is easy to understand. Right, 365 days in a year, your birthday's on 1 in 365. But things get trickier when we start comparing more people, because now I'm not just comparing myself to that one person, now it's to other people, and those people to other people, and so there's many ways you can start to compare, and as math starts to involve bigger numbers and more numbers, it can get tricky, which is why I was never very good at math. Because if something is tricky, it's not easy. It's difficult, it's challenging, it's not impossible, but you're not just going to sort of go, oh yeah, that's easy, and solve the problem in 5 minutes. If it's tricky, it's going to take some time, some effort, some bright ideas, or some help, because it's not simple. For example, some teenagers might find tying a tie to be tricky at first. Oh yeah, if you're tying a tie like a businessman, unless you go to a school where you have to do it or your parents teach you, the first time it's a little difficult. It's a little tricky.
So the article continues, in a room of 23 people, it might seem like there are only 22 comparisons to be made.
That's just me and them though.
One person's birthday compared to the birthdays of everyone else in the room.
Yeah.
In truth, there are 253 comparison pairs.
Me to him, me to her, me to her, her to him, her to... Oh.
So those are comparison, and a comparison is a noun, and it means when we say what is the same or different about 2 things, 2 or more things. So we make a comparison. So I could say, Even though she knows she shouldn't, Mary often makes comparisons between her children.
Ooh, don't compare your children. That would be the verb form. Or when you're buying things, which one do I like? Which one's nicer, newer, cheaper, better, whatever. You make these comparisons all the time. And in math, the more comparisons you make, as we said, the trickier the math gets. All right, let's take a break and then we'll be back to hopefully solve the birthday problem and also hopefully understand how to solve the birthday problem.
Yes.
Hello， 大家好，我是 Hanny。同学们认为在生活中要遇到同一天生日的人很难吗？我以前在国小、国中的班上都没有人跟我同一天生日，不过在高中的班上却有2个人跟我同一天生日，我们总共3个人同一天哦。好，那今天的课程要来破解生日难题。在23人的一个群体当中，2个人生日相同的几率是多少呢？A 5%。B 10%， C 20%， D 50%。想想看，答案是什么？答案是50%。课文写到说，这似乎令人难以置信，但是数学是正确的哦。这就是生日问题，是个经典的几率问题，它凸显了在大规模计算几率时的一个常见错误。我们来看单字 percent， 它表示%什么什么。我们在 percent 后面加上 age 变成 percentage， 那就可以表达比例啊、百分比、百分率。好，下一个单字 incredible 表示难以置信的、惊人的。我们去掉字首 in 变成 credible， 那可以形容是可信的或是可靠的。老师在讲解的时候有提到 blow one's mind， 这表示使某人惊讶、震撼的意思。好，那我们接着就来试着解题咯。首先，2个人生日不同的几率是365×364，那这换算过来也就是99.73%。这部分是容易理解的。可是当我们开始比较更多人的时候，事情就变得比较棘手咯。在一个23人的房间里，假设我是有包含在那23人之中，以我来看，我似乎只要跟剩下22个人比嘛，跟他们生日相比，那就只有22组要进行比较。可是其实呢，有253组要比较诶，我们待会再来说这部分。那单字 tricky 就是棘手的、困难的，我们文中只是用到它的比较级 trickier。那 Mike 老师在讲解时，他用到 challenging， 就是把 challenge 字尾的 e 改成 ing， 变成 challenging， 就是具有挑战性或是困难的。再来 comparison， 它表示比较，是个名词。好，这边2个重点，我们进入文法时间。好，我们来看第一个重点是 on a large scale， 它表示大规模地。那么其中这个 scale 在这边当名词，它表示规模啊、范围或是程度。那么 large 你也可以改用其他形容词，像是 global、grand、small 等等来表达规模的大小。举例来说 ，The holiday is celebrated on a national scale。那个节日是以全国性的规模来庆祝，也就是说啊，那是个全国欢庆的节日。好，在第2个重点是 seem 当连缀动词，它表示似乎、好像。那以下介绍几个常见用法。第一种，你用 seem 加上形容词，像 They seemed uninterested， 他们似乎不感兴趣。第2个用法，你可以用 seem like 加名词或子句，像是 He seems like he's made up his mind， 他看起来似乎已经下定决心了。那第3个，你可以用 It seems that 主词加动词，其中的 that 可以省略。那你也可以把这个 that 子句当中的主词移到句首，把它改写成主词 seem to 加原形动词。例如 It seems he has a crush on you， 你也可以把它写作 He seems to have a crush on you， 他似乎喜欢你，迷恋着你耶。好，那我们接着回到课文中。
The first person has 22 comparisons to make, and the second person has 21 because their birthday was already compared to the first person. The third person then has 20 comparisons, and so on. To calculate the probability that no one in the room shares a birthday, look at the following equation. 364 over 365 to the power of 253 is approximately equal to 0.4995, which is equal to 49.95%. the chance of two people having different birthdays is 99.73%. But when this comparison is performed hundreds of times, this probability drops to 49.95%. Therefore, the chances of a match are 1 minus 49.95% equals 50.05%. So, there is a 50% chance that 2 out of 23 people share a birthday.
All right, so if you're just comparing your birthday to a bunch of strangers, it would be hard to find one person who matched you. But with a group, there's many more ways to compare. As the article explains, the first person has 22 comparisons to make. A group of 23, I'm one, I can compare to the other ones, the other 22. And it says the second person has 21 because their birthday was already compared to the first person.
Oh, okay,
so they won't
right.
compare again.
Okay, trying to get my head around the math here. Okay, the third person then has 20 comparisons, and so on.
Okay.
To calculate the probability that no one in the room shares a birthday, look at the following equation.
All right, here we're getting into the math. So look at that equation with all the numbers, the brackets, the little numbers, the big numbers, everything. How would we read that? We would read it as 364 over 365 to the power of 253 is approximately equal to 0.4995, which is equal to 49.95%. 50%. 49.95.
Right,
That's basically 50%.
If you round that up, it's 50%.
There you go. So, following the math, the chance of two people having different birthdays is 99.73%. But when this comparison is performed hundreds of times, this probability drops from almost 100% to 49.95%, about 50%. In other words, like flipping a coin.
Right. So that means if you went around and just asked random people, you usually have to ask around 100 people before finding someone who has the same birthday.
Oh, yeah.
But in terms of your class, with being 50% of the time, there will be someone in the same class with the same birthday.
Sounds good to me, Professor.
Okay. So we have a vocabulary word in there, which is to perform.
Right.
So if this is performed hundreds of times, meaning if you carry out an act or a task. So to perform something like an experiment, to perform this test, to perform
a study.
A study,
perform
yes.
Some
So
research.
Usually something that involves more than one action. So usually involves multiple steps to complete it, and that's when you perform something.
It's kind of like do, but in a more formal way. And of course, we also use it to talk about when you're doing art on stage. You perform, you dance, you sing. But here, when you do the math problem or just, do all the paperwork with your math, you're performing a problem or performing a calculation.
So an example sentence, before performing the experiment, the scientists took the proper safety measures.
I think we could also say before doing the experiment.
That's right. In that case, you can also
In
substitute
that case,
it
it
with
would work.
do.
All right, so back to the math.
Therefore, the chances of a match are 1 minus 49.95% equals 50.05%.
50.05%. So what does that mean?
So there is a 50% chance that 2 out of 23 people share a birthday.
There you go. That's exactly what we said. That's exactly what the math shows. And if you don't understand it, ask your math teacher to explain. Let's move on to our what do you think question. What do you think, Matt? Were you surprised by the answer to the birthday problem? Why or why not?
You know what? Now that I think about it, I was not totally surprised.
Really?
Because I think a high school math teacher of mine explained this when I was in high school. So
okay. I must have been sleeping that day.
They didn't actually explain the math problem behind it, but they just told us that it's likely that in your class there is someone who shares the same birthday. And then they demonstrated it by asking everyone in the class their birthdays, and because there were 30 of us in the class, there was an even higher than 50% chance, and we found 2 people with the same birthday.
There you go. And when you're talking about probability, chances, percentages, things can be really different than what you might expect. I would have guessed a bigger number of people. Nope, 23 is enough. So there you go. When people start talking about your chances of winning the lottery or your chances of this or that, be careful because the math often goes very, very far away from what you would naturally think. Thanks for joining us, guys. We'll see you next time. I think there's a 100% chance we'll see you in the future.
Yeah.
Take care. Bye-bye.
Goodbye.
刚刚说其实有253组要比较，这是因为啊，第一个人呢，他有22组要比嘛。那么第二个人呢，就有21组要比，因为他的生日已经跟前面的人比过了。好，那接着第三个人他就是有20组要比，所以我们就以此类推，你就用22加21加20一直加到1，最后就会得到253这个数字。那我们前面提到说，两个人生日不同的几率是365分之364，也就是99.73%。你现在就是用这个365分之364乘以365分之364，一直乘下去，然后你发现这个东西它的253次方大约会是0.4995，也就是说啊，当进行数百次的比较后，几率会降到49.95%。那我们再利用这个1减掉49.95%，你就会得到50.05% 这个数字了。所以呢，23人当中有2个人生日相同的机会是50%。好，那我们最后来看单字 perform 这个动词呢，它就表示做或是执行，它也常常用来指演出的意思。好，再来补充单字 probability， 它表示几率或是可能性。那么 equation 它表示方程式或是等式。老师们在讲解的时候有提到 bracket。bracket bracket 就是括号，还有提到 random random 可以形容是随机的或是任意的。好，那么以上今天的讲解，同学别走开，马上回来哦。
Question. In a group of 23 people, what is the probability that 2 people share a birthday? A. 5%, B. 10%, C. 20%, D. 50%. The answer is 50%. That may seem incredible, but the math is correct. This is the birthday problem, and it highlights a common mistake when we're calculating probability on a large scale. To begin with, 2 people have a 364 out of 365, or 99.73% chance of having different birthdays. This part is easy to understand, but things get trickier when we start comparing more people. In a room of 23 people, it might seem like there are only 22 comparisons to make, one person's birthday compared to the birthdays of everyone else in the room. In truth, there are 253 comparison pairs. The first person has 22 comparisons to make, and the second person has 21 because their birthday was already compared to the first person. The third person then has 20 comparisons, and so on. To calculate the probability that no one in the room shares a birthday, look at the following equation. 364 over 365 to the power of 253 is approximately equal to 0.4995, which is equal to 49.95%. The chance of 2 people having different birthdays is 99.73%. But when this comparison is performed hundreds of times, this probability drops to 49.95%. Therefore, the chances of a match are 1 minus 49.95% equals 50.05%. So, there is a 50% chance that 2 out of 23 people share a birthday.
Hi, I'm Josh.
I'm Kiki.
Today we're going to be playing Guess the Bear. We each have 3 cards with words or phrases on them, and we have to try and guess what they are in 1 minute as they're replaced by the word bear. So Kiki,
I'm gonna go first.
yeah, take us away.
Start the clock. Adjective, 1 word. The artist has done some bear work in sculpture. She told an bear story of survival in the wilderness.
A exciting.
No.
Good.
No. Okay.
All right.
Next one. Phrase, 2 words. I've just met him, but he bears a nice person. It bear, you're upset. Want to tell me what happened?
I reckon that's probably going to be seems like. Seems like?
Yes, yes. Okay.
Yeah, no.
Last one, noun, 1 word. A large bear of our income goes to taxes. The chance of rain this weekend is about 25 bear.
Would that 20 bears be percent?
Yes.
Percent.
Yes, percent. Okay,
25.
so the one that you didn't get was an adjective, incredible. The artist has done some incredible work in sculpture. She told an incredible story of survival in the wilderness.
Okay. That makes sense. Well, good luck with these, mate.
Okay.
Let's start that clock.
Right.
Adjective, 1 word. This puzzle is fun to do, but it's very bare. My brother asked for advice with a bare situation.
Difficult.
No.
No?
Very close, but no.
Okay.
But let's just move on,
Okay,
mate. Let's just
okay.
move on. That was insulting, in fact. Noun, 1 word. She's so tall, her father looks short by bear. I'm from a cold country, so this place is hot in bear.
No.
It's a noun. It's 1 word. She's so tall, her father looks short by bear.
Oh.
I'm from a cold country, so this
don't
place is
know.
hot in bear. Okay, we'll
don't
come
know.
back to that
Okay,
one.
we'll go.
Phrase, 4 words. This company produces stationery, bear, 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 bear. They hope to manufacture cars, bear, 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 by next year.
On an assembly line?
No, no. This company produces stationery, bear, bear, bear. They hope to manufacture cars, bear, 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 bear. It was on a large scale. Phrase, 4 words. This company produces stationery on a large scale. They hope to manufacture cars on a large scale by next year. And she's so tall, her father looks short by comparison. I'm from a cold country, so this place is hot in comparison.
Okay.
Yeah, it gets easier when you know the answers,
really
doesn't
hard.
it?
Yeah. And there's one more, right?
There's one more. No, I think you got them all. You got them all except for that one. This puzzle is fun to do, but it's very tricky. Oh, no, you didn't get that one either. My brother asked for advice with a tricky situation.
Oh, tricky.
So you guessed difficult, which is